MEPHISTO seminar. Samuel has completed a joint PhD at the University of Ottawa in Canada and at the Université de Lorraine in France. And his dissertation dealt with naturalized Kantian epistemology. And now you're currently pursuing postdoctoral research at Liège and in Bochum, right? And you're working on a historical project about the critique of Kant's concept of intuition, right?
Yes.
And today you will give a talk on Helmholtz as a case of Neo-Kantian naturalized epistemology.
Yes.
And you have 1 hour, the floor is all yours.
Perfect. First of all, thank you for inviting me. I'm really glad to be here and share some of the outcomes of my PhD research, and also you'll see at some point my postdoc research are coming up as a question. If you have ideas, please let me know. I'll be interested to know them. So basically, just general context, my PhD was a comparison between 19th century Neo-Kantian naturalized epistemology. So I claim there's something like a Neo-Kantian naturalized epistemology, and to compare that with Quine, so normally known as like the father of naturalism. And you'll see there are some undertone of that here. I decided today to talk to you a little bit about Pihlström approach, really a little bit, as an inspiration to actually make sense of everything that I researched in my PhD, and trying to bring that together so that it makes some kind of a really coherent interpretation of Helmholtz. I won't have a deep dive into Pihlström work. There will be one slide where basically I will use 3 elements to just kind of give an orientation to the talk. Please, if you have questions there, I'll be really happy to further talk about that. Last thing, there was supposed to be in my abstract, it's mentioning the notion of context of discovery, context of justification. I won't explicitly introduce it. It will be part, you'll see, of Friedman's interpretation. It will come out quite naturally, along with the super-known internal, external questions that you find in Carnap, among others. The talk will be 1 hour. I'll take the 1 hour, and therefore I could not just go through that. If you have questions there again, please feel free to just ask later. So, first thing first, I won't assume that everybody knows Helmholtz, because Helmholtz is a quite minor figure compared to other people, like Kant, for instance. Helmholtz is known for work on different fields. He's first and foremost a physician, so he worked on geometry, topology, physical space, conservation law, electrodynamic, thermodynamic, free energy, and on top of everything, he did a bit of epistemology. In few of his texts, those that will be of interest to me is, so to say, the intermediate period in Helmholtz, which encompass psychophysiological work, among others, the 3-volume treatise of physiological optic, and also there are 4 texts actually. There are 2 that have been published the same year, but on non-Euclidean geometry. Those are, so to say, what normally when people talk about Helmholtz, those are the main texts they are discussed. There are a lot of other people who go further than that, but those are like the core texts that people discuss. What I want to do today is a, let's say, 2-part presentation. The first part is to introduce you to Michael Friedman's interpretation of Hermann von Helmholtz's 19th century Neo-Kantian epistemology, which I would try to convince you is shaped through this Vienna Circle anti-metaphysical commitment. So when he's reading it through this lens that is really anti-metaphysical. And the second part of the talk would be on, let's say, I will draw on Sami Pihlström's work to try to convince you that actually what we should be looking at is a pragmatically naturalized transcendental epistemology. So little difference here, and you'll see that there's some kind of metaphysics that still is present in a precise, really tamed way. But still, this anti-metaphysical commitment cannot work. So two objectives, general one, to introduce you to Friedman's reading, which is kind of the introduction reading or the standard reading that one could have, that is really reliant on geometry, among others. There's other people who have written really really good work on Helmholtz, among others, Gary Hadfield, if you're interested. That's a really good book. But it's really the Friedman reading that interests me. And the second objective, once you're now Helmholtzian, convinced, is to showcase that, to me, there is, in the 19th century, in people that we barely know, there are Neo-Kantian who showcase some kind of conceptual resources. They have conceptual resources that are relevant to contemporary work that we see today. Among others, the discussion that Sami Pihlström is leading with a lot of other commentators or philosophers. Most of Sami Pihlström's work is through those comments, so really discussions. And I think those people are always going back to Kant, because that's how we build a canon. We like those really important figure. I would argue that often going back to Kant will raise some weird questions sometimes. Most likely I'll have something at the end like, is it really transcendental epistemology? Can we really say that? Which, when you look at what those 19th century people are doing, you actually have resources, because they already are into this naturalizing process. So if I made you today Helmholtzian, and you understand that you can use that to be able to challenge, to understand or to challenge what people are discussing today in contemporary epistemology based on that, I will have achieved my two goals. So we'll see if it works. So the talk, basically, to be more precise, on the Friedman aspect has 3 points that I would talk about. So principle of causality and likeness. We'll talk about his empiricist theory of visual perception, and then talk about space problem. And you'll see the 3 of them are kind of feeding into the space problem. That's the main problem. That's how, for me, Friedman reads Helmholtz. The second part, what I will do is try first to give you an epistemological framework to explain to you how Helmholtz is understanding philosophy and how that shapes actually the same notion of causality and the likeness, as well as the as Helmholtz's position on empiricist versus nativist debate. So we'll go back over again on the same 2 subject or topics, to allow you to see really the difference, what for me Friedman is missing and what should be actually there. So, without further ado, Friedman and the notion of anti-metaphysical reading of Helmholtz. So what is to be known is that beginning of Helmholtz's career, so 1855, on human sight, Helmholtz will argue that causality connects observable appearances to unobservable external causes. So we reach the external world only through causal inferences. Causality is a law of which thinking is prior to all experience. So what you have, if you want to give an example, is a telegraphic system. So you have something that transmits a signal caused by external events. So sensation is conditioned by something that exists or happens that is prior to this signal. And the nervous system mediates between signs and reality, enables representation, even if the mediation makes real causes hard to identify. So you have here, so to say, the idea, we never immediately perceive the objects of the external world, but we only perceive the effect of these objects on our nervous apparatus. And this has been so from the first moment of our life onward. In what way, then, have we first reached across from the world of sensation of our nerves into the world of actuality? Obviously, only through an inference. We must presuppose the presence of the external objects as cause of our nerves' excitation. From there be no effect without a cause. So The principle of causality cannot be an empirical proposition here. It is given before any kind of experience and makes it possible. So causality functions as a precondition of experience, not as a result of it. No cause, no effect without a cause is a law of thinking given prior to all experience. So what you have here is basically causal realism, really banal or idea of what causal realism. You have objects, they're causing something, you cannot really know what they are exactly, but they're there and they're influencing your senses. There's a major shift that happens in the period that is most interesting to me. This shift is super important because Helmholtz came to see the principle of causality as fundamentally about law-likeness in appearances themselves, not as a bridge to things behind appearances. So Helmholtz will explain that the principle of causality is nothing other than the presupposition of law-likeness of all the appearance of nature. What we find unambiguously as facts is the law-likeness in the appearance itself. How does he explain that? He will basically use a distinction in his article in 1878 between the notion of signs and images. He will explain that in as much as the quality of our sensation give us a rapport of what is peculiar to the external influence by which it is excited, it may count as a symbol of it, but not as an image. But a sign need not have any kind of similarity at all with what it is the sign of. The relation between the two of them is restricted to the fact that like objects exerting an influence under like condition evoke like signs. And that, therefore, unlike signs always corresponds to unlike influences. So what you have here is the fact that signs that are given by your nerves have a cognitive value, but they do not mirror any kind of external reality. What signs can give you is an image of a law, of a regularity that governs events, a representation of what is often referred as a nomological, law-governed process. It is this like objects, like circumstances, like signs, unlike signs, unlike influence. So you get the idea there, I hope. That's how Friedman presents the notion here of law-likeness in Helmholtz. Then we have the empiricist approach. You'll see both of them are kind of intertwined. In many of his work, but especially in his handbook of physiological optics, Helmholtz will develop in a debate against nativism an empiricist approach. So nativism, empiricist, it's basically a debate about do we have what we call stereoscopic vision, so 3D vision that is given from your two retina and recomposed into this world I see now in front of me. Is it explainable via innate physical resources, how my retina work, how my nerves work, or do I need something else? Is it my brain that processes those physical stimulus and therefore have some kind of a non-reductive approach to it? So basically Helmholtz will take the empiricist, that means we learn to see, side of the debate, while he will attack the nativist hypothesis. Nativist hypothesis has been developed by a lot of people, among others somebody that is really important for Helmholtz, Johannes Peter Müller, Kund, and especially in this case, the whole debate is centered around Ewald-Hering interpretation. So let's say the main thesis, if you want to decompose it, is that there is a complete fusion between sensation from both sides of the eyes, assuming, for instance, that fiber corresponds coming from corresponding retinal region joined in pair into fibers that each transmit a single sensation to the brain. So what you have, as in the image there, is that you have on your retina points where the image of, for instance, a bottle or something like an object is reflected. And the idea there, which is how Helmholtz described the nativist here, is that the fusion of those images would be made directly on your retina. So corresponding point from the projection of the bottle on my retina. That's where the recomposition of space starts. The problem with that is that if you assume this, that there is a perfect matching in between the bottle, what's on my retina, you end up with a problem of what we call the Raumgefühl. So the sensation that I have of 3D space. How do we account for that? Because my two retinas are 2D planes, and unfortunately the representation that I have is 3D. So somebody like Hering has to say, aside from just the physical retina, how they're working, has to account for this feeling of depth through what he calls a sense of spatial extension. So you do have direction, horizontal and vertical position that are directly on the retina, and then you have this Raumgefühl that is somehow projected over those matching points so that you have this kind of depth of perception. Sounds maybe weird. We'll get to that afterward. So the consequences that you have here is that for an activist like Hering, what is the most important part is the physiology of your retina, how they're functioning, how, for instance, the pairing of the words corresponds to nerve fiber, how the eye muscle activity works here, the intensity of the stimulus, how clear it is, and the conditional chemical of the eyes. That's what's going to be really the most important. So yeah. Now for Helmholtz. Helmholtz has what we would call an empiricist, non-reductivist view here. Spatial perception is first and foremost learned, based on experience and association. The general idea, he will retake some of that kind of nativist approach by saying that the image of corresponding points are localized in the same region, while those of not corresponding points are localized in different region of the common field of vision. However, both parts of the rule are subject to small deviation when we combine the two images into the notion of a solid object. So you kind of see first, I talked to you about law-likeness, you kind of see law-likeness appearing here by having this corresponding region. What's important here is that there might be a slight divergence. It's not because for Helmholtz you have those 2 points that are directly on your retina that necessarily there is a perfect coherence or correspondence with the object. It's not a perfect mapping. There are many reasons why that kind of mapping would not work. So what's really the most important part of it is really the association. You learn to interpret those signs that are given on your retina. So what you have in a non-reductionist view here, you don't need to presuppose that there is fixed, innate physiological link between the retina excitation and the representation you have. You can kind of break it. You can keep, let's say, the retina mapping as like a methodological process. It's a nice one. It works quite well. It gives you law-likeness, but there is a whole process, unconscious process of interpretation we see there. Helmholtz presents what he calls inferential processes as involuntary association of ideas that arise from the fact that two representations, having very frequently occurred together, inevitably call forth on one another according to a certain natural necessity. So what you tend to end up with is something that looks like a strong empiricist-ish approach. The frequency of association is important, together with the degree of certainty accompanied by the vividness of the representation. This gives then an apparently necessary and involuntary character to those images. That's basically why when you see an illusion, it's really hard not to do it. Your brain is already involuntarily forcing you to see the illusion. You cannot really exactly get out of that. So that's what the second point of Friedman's reading, this empiricist approach. And what's important for me is that especially Friedman kind of goes really quickly on that to end up with the space problem. So now is like the crunchy part of the presentation. I tried to tame down everything here into something that is digestible to understand in general. So the little points of detail, if you want to have more information about that, ask me after. I try to just crunch it down and make sure that everybody understands what's going on here. So the space problem here comes from Kant, actually. You have this idea in Kant that not only do you have the general form of spatial intuition that is given, the outside form of your intuition, it's transcendently given, but it also contains advance and prior to any possible experience, certain narrower specification as expressed in the axioms of Euclidean geometry, precisely. So geometry so there is geometrical presupposition that appears to us as necessarily correct. So for Kant, it allows for the construction of Euclidean concept in concreto, that is in pure intuition. So you can build, we've all done that when we were young, you can trace a line, then you use a ruler, a compass, then you can make a triangle, you've proven you can build a triangle. All those Euclidean demonstration. What's important here is really the pure intuition, isn't really this triangle. This appearance necessarily serves as proof of the proposition are given a priori, prior to all experience, and necessary, they're universal. This spatial intuition involved is a transcendental form of intuition, is therefore independent of the empirical experience. What's really important here is really this transcendental form. It's not simply something that is given to you a priori, it's also infused with those Euclidean axioms. So that, for instance, you can define a straight line as being the shortest point between, the shortest relationship between 2 points. You can create a plane if you extend a line into another dimension. You can have a parallel postulate, for instance, if you're tracing 2 lines that are never going to meet one another. So Euclidean geometry, I think you all have the basis here. There's problem there, 2 problem. In fact, the first one being we do have in our daily life experience of Euclidean geometry. You can think about projection of a plane onto a sphere, which leads to change of geometry. But the real problem, or the real reason why Helmholtz becomes really interesting in that, is that you have Riemann Habilitationsschrift that is being produced, and it introduces a series of hypotheses which lie at the basis of geometry, and that allows you to have non-Euclidean geometry with positive curvature, specifically. So you can have geometry over spheres. So now Helmholtz wants to see, that's the fundamental, let's say, project of Helmholtz. Helmholtz sought to replace abstract Riemannian hypothesis with really factual observation of congruence. So the invariance of spatial magnitude by what we call here truth or factual signification. So what we want to have is those facts that allows you to measure space, for instance. And those facts that are allowing you to measure space will eventually encompass or make possible many type of geometry, not simply the Euclidean one. Although the Euclidean one for Helmholtz is like the by default one, that's the one we prefer, that's the one he first defended, and that will change. So how do we do that? How do we get some truth of factual significance? There's one concept that is in Helmholtz's thesis super important. It's what he calls the free mobility of rigid bodies. If you can, that's the whole bundle of facts there. If you can define that, basically you have everything you need to be able to do measurements in physics. So let's decompose that in 3 points, in 3 aspects. There are actually 4. There's one that is left behind. It's not really that of a problem. We can talk about that later. So 3 points. The first one, you need dimensionality. You need to define space as a n-folded extended manifold, so with a number of dimension. Those have to be continuous and independent measurement of each point in space, so that's super important. The number of coordinates you will need there will be a direct relationship of the quantity of n-fold extended magnitude or the quantity of dimension you have. So for instance, when you have my vector there, it's on a plane, you normally give 2 coordinate because 2D. So you can localize and tell me like how big my vector is. And it should be non-differentiable function are excluded here. Can talk about that later. What's important, once you have defined the notion of dimensionality, what you want to do is basically have a rigid body that you will define as a meter stick. So if I want to measure, for instance, how big this table is, what I first need to say or to define is some kind of a stick. And I want to know also how the table is going to behave. Because if I want to measure something, I don't want my measurement to be moving while I'm trying to measure to know like how big the table is going to measure. So you have 2 rigid body, my, let's say, meter stick, and the behavior of the world. So what I want to do here is the notion of congruence that is becoming super important. What I'm going to do is to use this to be able to place it many, many times. And to define here, congruence would be how many times I can use the same length, for instance, and bring it back to be able to measure. So what I have here to assume is that there will be minimal deformation of both my meter stick and the thing that I'm trying to measure. Between any pair of points of a fixed body, there will be an equation that is independent of the motion that would exist. So basically what you have here, my vector is basically the equivalent of a meter stick of my cell phone. I can make an equation that will allow me to decompose this vector into 2 points. We are in a 2D space. And in between those 2 points, let's say the little end of the arrow and the beginning of the arrow, there will be an equation, Pythagorean equation, that you all know, you've all done, that allow me to say like, what is the distance? So now what I have defined here is basically a rigid body, a meter stick. Like I know in between 2 points, there's an equation that exists. And the last part, we said dimensionality, rigidity of body. I have to be able to move this around without having any kind of deformation, so maintaining the length of all my vectors. Once I have that, I can have distance invariance. So I can have an independent, so the same, the length of my vector will be what we call independent of the position. So my space is not going to make it shorten or get it bigger. So I have this kind of invariance that is here. That gives you basically what we call topological invariance. You followed me? That was the trickiest part. It's how do you measure? You apply this vector, for instance, 3 or 4 times, and then you know, for instance, how big a table is or how far a particle went. What's important here is that I define what is a rigid body. Initially, Helmholtz thought in his really early work on geometry that the only type of geometry that was really working was Euclidean geometry. 3-dimensional, free mobility, and also infinity. Exactly, it would be unboundedness. So you have to be able to move it around. After learning from Beltrami's Lobachiewicz's geometry, so negative curvature of space, he realized basically that free mobility, so the thing that I defined here, does not actually entails Euclidean geometry. What's really important is constant curvature for Helmholtz. So constant curvature, you have many types of space that do allow that. The neutral one being the Euclidean one, but you also have those 2 types, so positive and negative curvature. So that's important. The second thing is unboundedness, which is also super important, which is not one of the property of Riemann's geometry with positive curvature, but with negative curvature. So this Beltrami-Lobachiewicz's geometry. So what you see here is that through this definition of how do I measure free mobility of rigid bodies, I kind of redefine geometry. That's what Friedman is putting forward. So we now know that Euclidean geometry is not built into as an essential character of space. Those axioms are not necessities of thought or of intuition. They flow from the concept of measurable manifold. They are not necessities of intuition. We can imagine basically pseudo-spherical geometrical construction. So it emerges somehow the type of geometry you're going to use as an empirical fact about measuring instruments. So you don't need to say that they are that the axioms are given a priori. They're just about facts, empirical facts about how do you measure stuff. However, Helmholtz is still find it super important to say that space can be transcendental without the axioms being given so. Space can be transcendental as Kant held, even if the axioms are not, because the most essential feature of spatial intuition, including free mobility, constant curvature, derive from the law-like experience of bodily motion underlying objective localization. Why is that important? Because here, what's really going to be the crux is that what's important is the objectivity. What you want to be able to do here is that you want to be able to produce measurements about reality. Everything that has to do with the choice of axioms, but also eventually the metaphysical framework in which you're going to put it, are not going to be questioned here that is really something to be decided a priori. It will be either in the case of axioms for Helmholtz decided empirically, or in the case of the metaphysical framework in which you can place this measurement device as a choice. If you want to, so what you have here is some kind of an internal-external question that are appearing. You have the possibility of having many type of geometries. You also have, Helmholtz say, what is really important is the actual measurable law-likeness, so my procedure on how to measure with my little meter stick I defined. But that can be placed into an empiricist, realist framework, which was going to use the vocabulary of ordinary language about mid-sized objects. So if I'm talking about this being my meter stick, for instance, it exists independently of me, and I'm able to measure this outside. That's a metaphysical commitment that I'm having here. Helmholtz tells us that there's also a subjective idealist way to do that. You don't really need to assume that reality exists here as physical objects to be able to apply this measurement device. You can also do it with what he calls the law of causality, so the law-likeness, the illogenic and topogenic moments. Not going into a lot of details, the only thing that is important is that what you need is only to see in this grid the hylogenic moments, which are where the hyle, the matters, the sensation is, so those dark squares. And you have to have some kind of topogenic moments, so some kind of a grid, space that is given. And from that, basically, if you have all done a bit of computing, you just have something that moves from pixel to pixel, and you can see what stays the same, what remains the same with this invariance we've defined before, or the points that just change randomly so that I cannot bring them together. So I don't need here to really assume that there are objects outside of me. I can do in this really subjective or phenomenalistic approach, I can do also the same kind of measurement device. So what's important here, I told you we are kind of seeing this internal-external question arise. It's basically those elements that are arising here. So just a summary of what we've seen up to here on Friedman. What we have is a criticism against causal realism. There's a law-likeness that appears to be simply a principle governing appearances themselves. There's an empiricist theory of visual perception. So you learn to understand the sensation that is being given to you by inferential pattern. And then you have this space problem, which becomes the most important thing. What we want to have is factual observation of congruence. That's what's actually there. I can, for that, assume that there are many axioms, set of axioms that are possible that will be determined empirically. And there's a tolerance towards the metaphysical framework you're going to use. So you end up with basically this internal-external approach about the framework you're going to use. So my claim here is that Michael Friedman's anti-metaphysical reading is actually influenced by this kind of Viennese Circle positivist logics, and that has to do, among others, by what's interesting him in his reading. He's comparing Helmholtz to Schlick, for instance, or Helmholtz to Carnap, or Helmholtz to Quine. So the crux, or the big arguments, the most important part is going to be this space problem. And that will give you have something that is a question about sense. It's about how do you measure objects in what's actually given. And then you have those two elements, possibility of many axioms that you can choose from, and also a tolerance towards the metaphysical framework you can use, you can choose to use with. Is it okay? Up until now, I think it was the big part. Now for the Pihlström's approach, which I think, for me, I'm more sympathetic to it. The goal here is not to say that Friedman's is reading Helmholtz totally false. My point here will be to show you that actually he schemes over a lot of really interesting stuff that will bring you closer to any kind of pragmatically naturalized epistemology. And that we should pay attention to that, because it's not true that we end up with this kind of neutralized metaphysical framework where you just choose which one you want and you have the axioms that are given, and you have already what's really important is facts that are given. I'm going to read that. It's a little bit long, but it will give us, let's say, the background that I need to be able to then bring you to where I want to bring you. So Pihlström, in many of his articles, is going to introduce us to what does it mean, this kind of pragmatically naturalized reading. That's one of the presentation. They look alike. What I mean by this thesis is that there are already some socially, culturally, and historically contained quasi-transcendental condition operative in our cognitive life. This condition, which we might also call structuring condition or necessary condition for our being able to cognize an objective reality with a certain intelligible and experienceable structure. In this way, the combination of naturalism and transcendentalism rely on a more fundamental, though essentially anti-foundationalist pragmatism. Pragmatism, then, is the key of the naturalization of transcendental condition. Like Kantianism itself, the kind of pragmatism, however naturalized, view of the world as a world with a human face, a face structured, and continuously changed and redescribed by our activities. There is no way the world is in itself in the absence of human, practice-laden ways of viewing the world. So there are here 3 points that correspond to the 3 bold elements that are there. Well, I'll first talk about the notion of contextualism, which is encompassing this notion of naturalizing transcendental philosophy that does not reduce the Kantian condition of science, but instead reinterpret those transcendental condition from within a naturalized framework, preserving their any role. So we're detaching ourselves from any kind of first philosophy. So we have contextualism. So contextualism, you have it more fundamental, though not anti-foundational. Second thing that will be important is, I give you the whole name, but it's basically the independence of scheme. So we call it the transcendental scheme or practice dependence with pragmatically postulated scheme independence at the empirical level. That's the whole title. Just call it there's a dependence and an independence regarding the scheme, conceptual scheme you're going to use. So the idea here is that cognitive experience always operate within a biological, sociological, culturally, historically situated structuring condition that are quasi-transcendental. This condition makes objective experience possible, but they are produced and reshaped through human practices within form of life, Wittgensteinian ideas there. Thus, they are a priori only in contextual, historicized sense, not timeless or immutable. And the third point that I will highlight here, if I think I have the time, to talk to you about the notion of value-ladenness. So the fact-value distinction here is a contextual and fuzzy one. We can distinguish them in specific contexts with particular criteria, but those criteria are themselves value-laden. So there is no absolute transcendental point from which you can have facts and values. Both of them are always intertwined together. So I hope from those 3 points you're already seeing like how far or how a little bit aside I am from Friedman's interpretation. So thanks Pihlström for that kind of elements. Contextualism. The first thing that I want to do with contextualism is to give you the general, like, what is epistemology for Helmholtz? How does he define him? So, according to Helmholtz, philosophy and natural sciences encounter the same problem for two opposite sides. So the two questions here, the same problem they have is, what is truth in our intuition and thought? And in what sense do our representation corresponds to actuality? We've already seen this word, actuality, that is present. So what is philosophy doing? What is the side it's taking? Philosophy considers the mental side, seeks to separate out from our knowledge and representation what originate from the influence of the physical world in order purely to establish what belongs to the mind's own activity. What does natural sciences do from the other side? It seeks to separate off what is definition, designation, form of representation, and hypothesis in order purely to retain what belongs to the world of actuality, whose laws it seeks. There's a little bit of ambiguity in that definition. Philosophy studies knowledge and representation, or theory and perception, but also, in what he is giving us here, phenomenalist and physicalist conceptual framework. So what exactly is philosophy studying, and why is it one side? Natural sciences, when we look at definition, designation of form, representation, is also studying knowledge and representation, like what's definition, designation, and hypothesis, compared to law like of world of actuality. So they seem to be like some kind of recoupling. Both of them are actually just trying to understand how knowledge represents reality. And the second problem, so first problem, there's an ambiguity. Second problem, we said previously that Helmholtz, and you've seen it with the Friedman's reading, is a Kantian. So should philosophy investigate the condition of possibility of experience and knowledge to ground natural sciences? So it should be like a grounding process that allows you to give validity, objectivity to natural sciences. So philosophy or science, are those both two perspectives on the same objects, or do they have the same objects and problems? What I will argue, controversially, but I think with Pihlström's ideas, is that what we actually have is a continuity between both of them. We don't have a grounding relationship. What we have is a kind of agreement between physiology and what are Kant's doctrine. It implies basically seeking an epistemic foundation in the objects of empirical investigation. So Helmholtz would told us that the physiological investigation on sense perception leads us to the ultimate elementary process of cognition. However, we can see here that Helmholtz has a scientific approach to that, so he wants to understand how normal functioning eyes works. But then, if you're really working on how eyes works, you're going to end up thinking maybe about unconscious inferential process. You're going to think at some point about how do you express that through language, judgment. You're going to think at some point how you're going to think about the geometrical structure of the visual field. And at some points, you're going to end up talking about the condition of possibility of science. So there's some kind of a all-encompassing approach that looks, if you know Quine, that looks a little bit like Quine's idea, quasi-Quinean. We can talk about that later. Epistemology, that's the Quine typical, you most likely all know that. Epistemology or something like it simply falls to place as a chapter of psychology and hence natural sciences. It studies natural phenomenon, a physical human subjects. This human subjects is accorded a certain experimental control input, certain pattern of irradiation in assorted frequencies, for instance, in the fullness of time. The subjects then delivers an output, a description of three-dimensional world he sees and its history. So we seem to have something that looks like a anti-foundationalist and naturalized approach here. Most likely you're going to end up with a yeah, but there is a paradox here. There's a paradox. Seeking a Kantian epistemic foundation in the very objects of empirical investigation creates this. Cognitive construction imposes its own form to create experience, is itself a psychological process laying squarely within the realms of theoretical lawlikeness. And the form of the understanding are themselves expression of the theoretical lawlikeness. So in Helmholtz's hand, cognition took on the aspect of the theoretical law, discovering itself, a priori in the strong sense of both preceding experience and making experience possible. Inferences, so a priori inferences of invariance, are verifiable facts of our cognitive response, and because these inferences are therefore a part of the ongoing process of nature, it's not illogical to believe that they reflect the fact within nature. So we arrive at a position by first acknowledging that an a priori or there is a psychophysiological conditioning of experience. Once this epistemological constraint is established, it is qualified by the argument that as a result, so basically you acknowledge first that you have an a priori psychophysiological conditioning of the experience, you end up doing science and understanding that this kind of a priori conditioning is actually just the produce of you being a part of that lawlikeness. So there's some kind of circularity there that is present. So either you end up into a despair, you tell yourself that you cannot get out of that because you'll end up doing science and never being able to really understand what are those a priori constraints. Or you go for the Quinian approach and say simply that, well, skepticism is basically a produce of science. It is there, it's normal, it's not a default, it's actually a feature of the scheme you're working with. But the idea is that you're going to be working from within this contextual scheme work, this natural sciences scheme work. So you end up with those consequences. Helmholtz appealed to the mediation of a conceptual framework through which reality can be apprehended only indirectly or partially. This scheme works is influenced by natural sciences. Access to experience as well as conceptual articulation thus require acknowledging this kind of imminent position of the epistemology. A position is already shaped by a shared psychophysiological organization and the coherent network of statement characteristic of a given community. So you're working from within this natural sciences framework. Now, if you're a Kantian, you might be screaming, yes, it has consequences on necessity universality. So of course you don't have this huge idea of necessity that would be given to you by some kind of formal logical necessity, given to you by the logical principle of general pure logic that would be then interpreted into, for us human beings, into categories of understanding or pure form of intuition. What you end up with is kind of a mathematical necessity that is there, projected by the human psychophysiological condition onto the experience, which will basically legitimate the claim that involuntary association of ideas that arise from the fact that when two representations frequently present themselves together, one inevitably evoke the other. So there's some kind of a certain natural necessities we've seen previously in Friedman. So yes, we have material necessity there. And universality, well, universality also goes through the trap. You end up not with this universal validity. What you have is something more like an intersubjective agreement or recognition regarding the properties of objects in visual space and the validity of judgment. A priori rely on a common physiological, psychological structure, ensuring that at least some elements of our representation will be universally valid in kind of Kantian sense, that is intersubjectively. Since the universal validity is a consequence of human being, shared physiology and psychological structure, it is universal only for the human, or sufficiently similar being. So it's not an absolute universality, it is contingent on shared human cognitive and perceptual structure. So now we have this general epistemological definition in contextualism. Now, what about law-likeness? There is law-likeness and there is the epistemic afterward approach, and with that we can wrap up afterward. So, this kind of dependence of scheme reference, what's important here is that through his study, Helmholtz, in his theory of science, is actually deconstructing an idea you most likely already know that was coming from Locke. It is basically put together. Boring, right now, it's the commentator who's commentating on how Müller influenced Helmholtz. He says Johannes Peter Müller's doctrine shifted the old problem of perception of objects from explanation by representation of the objects in kind, Locke into first and second, primary and secondary qualities, to explanation in terms of specific functional relationship between terms, objects, and perceptions, which do not necessarily resemble each other. So we abandon the idea here that objects must necessarily represent something, primary qualities or not. What we have here is more of a functional condition. So in this switch, you have a change. It's not simply a change between causal realism versus something that is just empirical. What we have is a switch in metaphysics. It's a different type of metaphysics we're doing here. It's not a causal realist, it's a functionalist approach that we have. So property here are understood relationally. They fulfill epistemic function and contribute to the formation of reason explaining the subject's action, reflecting a pragmatic and epistemic-oriented approach. So metaphysically modest interpretation of experience, which is grounded in the natural tendencies of our organism to master its environment and expands the range of action. The second thing that is important, and what Friedman is not telling you about, because a lot of people do not really understand what is that doing there. I literally asked a teacher, like, what Fichte used there, and he made a joke, and basically the joke was like, well, basically Helmholtz's father was really a big fan of Fichte, and that's how it must have come into play, like that kind of derived ideas. What I try to convince you here is that actually what is interesting here is to avoid this kind of strict associationist approach. So basically what we want to do here is to use a general idea of Fichte ego and non-ego as a differentiation principle, so that from within my research, from within my psychophysiological perspective, I can already explain why, from within this scheme, I have something that belongs to me, something that would be scheme dependent, and something that would be scheme independent. How do you get internality and externality? Kind of Kantian move. You can see the idea that is behind it. So the idea here is to be able to somehow to support some kind of Kantian anti-objectivism by showing that cognition is physiologically conditioned, while at the same time maintaining also that we say something about the reality that we think is external to us, and that is not purely subjective, so that we don't end up into some kind of subjective idealism, fear of any kind of Kantian here. So this I and not I dialectic is kind of explained through the three processes that you find here. The first one, and let's talk about the relationship between voluntary movement and the environment resisting here. So you have the consciousness of when you're seeing, when you're trying to adapt. You can have, if you're really doing experience, you can have the consciousness of the intensity of volition effort you're putting into seeing something right and something that is not right. You can have, sometimes you have weird experience like that, but like muscular tension, if you're putting your eyes on the side, you're really seeing, you're really feeling that there's some kind of weird relation in between the tension that I'm feeling in my eyes and the thing that I'm perceiving, that allow me to say like, those are really, I'm doing something on the perception, it's not just happening. and the result of the effort, what I'm seeing. So through that, I'm externalizing somehow the objects that I'm seeing, my vision, and I'm also understanding that I have a subjective contribution there. The notion of attention has been put forward, not by me, but by Brian Trask in a really, really good and interesting article. Basically, he mapped out the relation, where the notion of attention comes up into Helmholtz's talk. And those elements of attention bring parts of the or features of the external world that corresponds to specific sensation, linking perception and objectivity. These features of the external world, he says, I take it just as given objectum, not I. So attention plays a role here. And also, that's super important, any kind of cognition will involve a intentional action for Helmholtz. There's some kind of what we call a know-how that is there, a canon, and a know-that, a wissen. Both of them are related for Helmholtz. Those are not two different categories. They have their specificity, you can separate them, but basically it's the same thing. So simply the process that your body is going through, your psychophysiological body, and recognizing objects, that's a canon. And it's the kind of canon that you can also have in a conscious way when you are actually swimming, for instance, and that you can formalize afterward if you want to have that into concepts, so that you have wissens that can depend. But the really important thing here is that your body is doing this learning to do this differentiation, so that what you end up with is a projection of the world that is present into this internal-external approach. So you can see here that Friedman did not talk to you about that. He was just talking to you about the notion of association and unconscious association that are happening. He's not talking about this differentiation process that is happening there. And what's super important here is that once you have this tricky differentiation process, there's also a pragmatic and understanding of truth that ends up with that is going with that. So for Helmholtz, there's some kind of pragmatic truth that emerges. The representation or symbol or natural sign used to guide action. Truth is evaluated by epistemic aim, so sensory accuracy, predictive capacity, eventually social validation and effective interaction. So it's not simply a correspondence, it's also a lot of values, practical values that are there. I have two sentences here that are coming from physiological optic. It makes no sense to speak of a truth, of a representation, other than a practical truth. The representation we form of things can only be symbols, natural signs of objects, which we learn to use in order to regulate movement and action. Other quote, a system of sign can be more or less complete and appropriate to its purpose. It thereby becomes more or less easily to apply, and the designation it provides are more or less precise. Different language provides us with an example, yet each allows to a certain extent to propose aim to be achieved. So what we end up here is this idea that this differentiation process is actually pragmatically ruled. It's a goal-driven mechanism that is happening that has ends. What's important here is that that does not only apply to how your body is interacting with reality, how we do unconscious inferences, it also applies to science. For Helmholtz, science is also goal-driven approach. There is no other truth than practical truth. So, general idea of what really science is supposed to be doing. The laws of nature are not things that we can modify by any speculative method whatsoever. On the contrary, we must discover them in the facts. We must test them through repeated observation and explanation, and knowing whether these results are consistently obtained under great exchange in experimental condition and in an even increasing number of cases, even as the means of observation becomes more and more refined. All this makes up more confidence in the reliability of their trust. So what we have here While truth initially appear as empirically grounded in repeatable results, and the aesthetic attitude is valuing confidence over certainty, the design of experiments introduce a pragmatic dimension. Theory function as an instrument to control and predict phenomena despite variation. What is important also, I'm not going to read all of that, but, and I think it will be the last thing. What is important in here is that causality is interpreted here as a methodological principle enabling scientific practices rather than inferential property deduced from empirical observation. So what we have here is this causality becomes some kind of a Kantian regulative idea. Completeness, systematic ordering, the search for an absolute totality of condition, which will be guiding scientific practices. Even though such totality cannot be fully realized in temporally conditioned practices. So it's kind of a focus imaginarium that we're going to aim at. What is super important, like at the beginning it says to us the law of causality actually is a given a priori, a transcendental law, but if you go directly to the end, he will tell us then it would still follow from such observation as occurred in law-like manner. It would still follow from such experience only by inductive inference, by superposing the law of causality, that the law of causality would then also hold in the future. Here's the only valid advice: have trust and act. So you see here that the law of causality, yes, sure, is a transcendental given law, but it is, so to say, submitted to this pragmatical approach. The only way to know that this transcendental law is working is to trust and act. So to continue to differentiate what is actually given to you in reality, actuality. So yeah, this trust becomes the most important aspect. I won't have the time to go to unless you really want a more 10-minute CEFISES, I'd say no. The idea, super simple, and you kind of see it, it's already emerging there. It was just an extension of that. It's to tell you that in the end, how you understand reality is not simply about facts, it's about also the value that you're putting inside of that. Helmholtz is giving us some in his debate over nativism and empiricism, is giving us some example, some arguments, and you would have seen that those arguments are, yes, about empirical really experience, but most of them are not about empirical experience. They're about epistemic values that we want to see there, again, to be able to trust and act upon. So in the end, what we end up with is this, if I'm just packaging everything together, the epistemological framework, you have a naturalist approach that recognizes that there is no first philosophy. What you have is always this scheme. You're working from within natural sciences. Law-likeness here is a biological, sociological, culturally, historically situated structuring condition, quasi-transcendental. On the epistemic theory of visual perception, what you would have seen is that the fact values are not distinguishable, they're both intertwined, so that the arguments you're going to have in science are going to be value-laden. And then you have this space problem, because if we're just looking at the space problem, what you end up with is kind of a validity of Friedman's argument. It seems to be a prequel to what's going on in the Vienna Circle. And my postdoc research right now are precisely putting this kind of pragmatically naturalized epistemology towards what's happening in the mathematical inquisition. Is there still some elements there that would not be reduced to simply this, what we want to be able to measure, what's actually in the experience by relying on many plurality of axioms and metaphysical decisions? Or is there some kind of pragmatically driven approach there? So that's just a comparison between what we've seen, but I'll end up here and have the questions.
5 minutes break?
Yeah. Perfect. it.
I have questions because I did not I'm not sure I understand Helmholtz exactly. So, because
Damn it.
you're reading. Okay. Pihlström.
Okay.
Okay. So, when you introduce Fichte, of course, you get this idea of the will, so you have this active-passive ontology that comes with it, and pragmatism. But after that, you said, yeah, but it applies to science.
Mm-hmm.
And I said, yeah, but in Helmholtz, it's essentially individuals. So it's the individuals that feel the resistance. And it seems that in science, when you talk about experimentation, of course you can talk about individual researcher doing an experimentation, but there's a collective aspect judgment that I don't see in Fichte. Is it introduced by Helmholtz, and how?
Yep. Thanks for the question. The general way, what you end up here, and I totally agree, is kind of that follows from that. Like, I'm seeing individually that there is this pragmatic influence relationship that divides me and the reality, and then we're doing science already. That's not exactly the jump that has to be made. There's a link in between both of them. The link here is that we are in a naturalist approach, which means that normally you have a continuity from first, how do you perceive reality, those sense inputs, up until the outcomes. The outcomes can be perception, but it can be also what Quine describes as its history. So it's also judgment that you're going to put on what I'm seeing. So what Helmholtz for me is doing is having this kind of, I would call it non-reductivist, but physicalism that is there, that allow you to understand sense perception from the very stimulation up to perception and the judgment that we're making as like a continuum.
Of individuals.
Yes, but they are then, and those are the elements that are prefigurating some stuff that you find, for instance, in Peirce, about values that are there, how it is important to have this intersubjectivity, possibility to convince other people. If I may just put forward some elements that I did not talk about, but when you look, for instance, as this empiricist-nativist debate, what's happening there is that you have the consideration about ad hoc hypotheses, or do you use them, do you avoid them? You have how do you present a debate, because that debate, it is presented as like that's a real debate that exists, but it's actually Helmholtz that is constructing that debate, and actually through Darwin acknowledging that you cannot refute nativism, and eventually it's a good position. So what we see here is that in how you're going to study perception, there's going to be epistemic values that are shared values there that are also important. So it's not simply as like jumping from I am a scientific in my lab, I'm doing experiment on how, and there are some really funny ones, which is just like if you poke your eyes, you will see like this little flash of light that actually shows you that you have an inversion in your eyes. Those are the really like simple, that's coming from me, like my fingers outside of the world is poking my eyes, subjective vision. But I'm also, I have to convince you about that. There's this intersubjective approach, and I can assume also that my experience will work if you are doing the same experience, because we have all the same body. So there you have different ways to, so to say, bridge them, either by assuming that you have the same body as me, so that you're going to have the same experience as I have, or by the fact that science here is present, and that how you're studying that, trying to understand, have a better reliability on how you understand reality, how there is epistemic values that are there, and how you're going to present debate and so on.
I have a follow-up.
Yeah, and then Charles.
So you just confirm my position. It's still an individualist position with values common, blah, 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 but it's not,
Yes.
It's always at the level of individual because we start from perceptions, and perception is private.
Yeah.
So it's not a kind of pragmatism that we would see later, after Peirce, after maybe 20th century, where people would put the decision or the rationality in the group.
So something that would be, that's really interesting.
Because at some part of what you were saying sounds like a strong program, for example.
Yeah, exactly. What's super interesting also is that if you look at Friedman and Pihlström, both of them will be talking about how you see Kuhn, for instance, this notion of relativized a priori. That's there. It is present. So those elements are there. My goal here was to also say it's not only individual. And just when you look at what Helmholtz is doing, how he's constructing debates, those are, like, yes, I would agree, it's coming from...
But he's a
First-
Neo-Kantian, so I can understand why you would say, okay, we start from individual to go to group
Yeah,
after.
totally. That plays a role. That's for sure. But when, for instance, you talk about causality being law likeness or a regulative principle to be able to do science, what you're talking about is not just applying that to how you do your work on your eyes. It's also, and that you can expand on work on field theory, for instance. On thermodynamics. So it becomes also, so yes, it's coming from this, like, let's say, individual approach, but there is a way to try to open that so that it's not simply causality is not simply rooted into me, it's also a social practice. It's also a scientific practice. But yes, it is coming from the individual and kind of opening there into this shared scientific practices. That's what I'm trying to bring, but I totally think it's a good point there.
This was super fun. Well, and I'm a card-carrying Helmholtz fan, so this was neat. I just did a 4-volume anthology on history of philosophy of science in the 19th century last year. There's 2 different Helmholtz excerpts. Facts and Perception, big fan. But there's one thing that I as a concept that I really like the way Helmholtz uses it. And it didn't show up here, and I'm just wondering how you bring it into your interpretation. So between the law likeness aspect and the kind of Fichtean will aspect sits experiment.
Mm-hmm.
And so he's got this kind of interventionist, manipulationist thing about experiment, where part of why experiment is good is that I know that I'm bringing about the change in the world that I see when I do it. That's why when I poke my eyeball, I did that because I can feel that I did that because I did it with my will, right? And that's there's fun echoes there of like other forms of interventionist philosophy of science in the 20th and 21st centuries. Like that's cool because we sort of doubled all the way back to talking that way again all of a sudden. But then there's also, there's something interesting here because then he goes on to say that like I'm also somehow, via my will, I'm coming to understand that when I do that, these things are connected together in a law-like way. And so I wonder, like, how do you see that playing into your interpretation? This kind of really interesting and sophisticated view on experiment that he's got.
Mm-hmm. What I gave you here is, for me, the tame version of what I wrote in my thesis, because there is a hidden type of causality or likeness that is there. So what you have, like let's say, to me, there are 3 types of likeness you can find.
Okay.
The first one being this really associationist approach. So that for me doesn't really make sense. I understand why somebody would put that. Helmholtz himself is saying, like in the quotes that I gave you, like it's association. It's a kind of necessity, Naturnotwendigkeit. So, but that doesn't really fit the kind of deductive approach he has, or quasi-deductive, where you have something that imposes on you. So you don't have simply the will to change how you think. Like it's already there. So for me, that doesn't really work. I think Friedman does it because it fits his Viennese Circle approach. It makes sense. There is the, let's say, condition of comprehension of natural sciences that is bigger. That was what I showed. And for me, there's another type which is a little bit more tricky, and it's a dispositional interpretation here. That will allow you to say, for instance, Helmholtz has all of this talk when he's talking about the fact that if I'm seeing Burgundy doesn't exist by itself in the objects. Burgundy is a relationship, so it only exists while there is something that happens with my receptors, for instance. And there I can understand that there is a law-like relationship here. And then he has a lot of, we can add some, like, we can go further into that. I did not touch into that, but like it's a dispositional approach. Eventually I would interpret it as a Quinean, so we can admit disposition as long as, the point, as long as you say they're going to be explained eventually by science. We would like to know a physical way. So we can admit that I see burgundy now. Do I have the whole causal process that would allow me to trace back what I'm seeing with what's stimulating that? No. But eventually there's a disposition here that makes it exist in this relationship, and I can take that as a way to experiment eventually, to try to understand what is the causal link there.
But the scientific explanation that will explain this disposition will not use the dispositional vocabulary.
Sure. The thing there is that it's the goal, and I would say, for Quine, it is clear that it has to be suppressed at some point. Like, I can admit that as long as it's just like it's an auxiliary. It's useful. There are some talks in Helmholtz for me about that, and I would say it's a non-reductionist approach. So there is still I think Helmholtz would still say there's a relationship that is there.
And part of that non-reductionism is the will again, right? Because there is this there's something very special about the fact that I bring things into existence. I bring conditions into existence.
Yeah. That makes them. This is this differentiation process that to me, it's about. For me, but it totally for me makes sense because it is about how Helmholtz is receiving Darwin's also there. It's how do I interact? It's not giving me reality as a transparent given. It's how do my body have evolved to be able to fit some. Call it epistemic values at large, being just the ability to track an object. That's something that was important for survival. Good. And it's still the same thing for Helmholtz in science. It's still something that we value to be able to explain through law likeness how if I drop my bottle, it will drop according to Newtonian physics, for instance. Cool. So that's how I think he's going. But yeah,
nice.
I'll be tamed on the disposition.
No, I really like it. Nice.
It's there. It's even another layer in that talk.
Yes, thank you very much. I have a couple of questions on Friedman's interpretation of Helmholtz.
Yes.
Because I think I just didn't get it quite right. First is about how he interprets Helmholtz on causality.
Mm-hmm.
So Friedman doesn't say that Helmholtz sort of tried to use it as an a priori. He just says that Helmholtz just derives causal relationship from appearance and that's it, or misunderstood you?
Okay. Do you have you said you had many questions. Do you want
I
to
have two. Yeah, the first one and the second is about the universality being psychophysiologically conditioned. In Friedman's view, is it the case, or? Okay.
So the first thing, Friedman gives talks about Helmholtz in many places. Behind that talk, it's a precise article that I use because to me it was the best article, but I would still defend that it's the Friedman's reading. It's about the comparison he's making between Helmholtz and Schlick. Because Schlick, if you don't know it, but Schlick took the theory of signs and all the important stuff that are about space problems in his own theory, and he's using that as how to develop his epistemological theory. So what really Friedman emphasizes is that we go through a acknowledged causal realism that you find into his Helmholtz's first work, where he is also applying really typical Kantian approach. That kind of fails at some point, like the Newton metaphysical approach on nature. And then he has to back up. And what Friedman's, so to say, rely on is this kind of associationist view. I would say it's not, I think Friedman here will also say that there is causality as a condition of comprehension that is there. He doesn't link it, and that I think is super important. He doesn't link it to the notion of trust and act. To me, that's really important because it still says that it is a relativized a priori condition. Like we are doing science here in our paradigm. This paradigm can change at some point. We might eventually change the import of causality, but that's now for the paradigm that we are in. That's what we presupposes. Maybe at some point it will be like entanglement and stuff like that, and might put But for now, that's a condition of possibility. So what I think is important also in that is that it also reduces a lot the possibilities to understand what causality is as law-like, and it's law-like actualities. So as Friedman presents it, it's a way for me, how I see it, to neutralize any kind of metaphysics. That's part to me of the whole reading. His goal right now is to everything that Helmholtz say about physiology, to read that through the space problem, where the only thing that is important is how do I measure? And how do I measure? I have a procedure that is given by those rigid body, the free mobility of rigid body. Everything that has to do either with the type of axiom I'm going to choose or the type of frame of reference, metaphysical frame of reference I'm going to use is not so important. What's important is how do I measure? And in Helmholtz, it's not so a choice that you will have in between the different type of axioms. It will be given by the space you're in while you're measuring. So I think that's where Friedman is going. It's to emphasize actuality and how do you empirically measure through that procedure he's giving you, and to put aside any kind of metaphysical implication and any kind of acknowledging that there is a plurality of axioms that are there. So it creates an anti-metaphysical interpretation, which to me, it's a bit too, like it's too much. There's elements in how Helmholtz is describing epistemology, how he is talking about putting all of those psychophysiological elements, saying like the only kind of truth there is this practical truth. To me, there is too much there that is present. And I would, if you allow me, I would add one thing. There's a super known problem with Helmholtz's description of space perception that will be pointed out by Schlick and by Poincaré. And basically that Helmholtz is kind of presupposing the Euclidean geometry when he's building this kind of objects. He's presupposing that Euclidean geometry is going to hold there. And Poincaré is coming and saying like, that's a problem, that's a convention that we're going to have. And I think that's what Friedman wants to put. It's like he was going through that, and at some point he failed, which is actually interesting because those are my postdoc research. Helmholtz actually considered this conventionalist possibility. He's saying like, but what about those axioms being analytic? And he says, no, I don't want that. That would be really weird. We would presuppose that just by a choice, it applies to reality, while there's something in between when I'm choosing the axioms and how do I measure that has to be built. And that's all his free mobility of rigid body. But that's also kind of metaphysics for me, or something that is there. So yeah, so the first question was that, and the notion of universality in physiology. I think Friedman has a more tame reading than I have. That's why I put it in my, like the revision of necessity, universality, and working from within. I put it on my side because it's a typical move of any kind of naturalized approach. It's not really a typical move of what Friedman is proposing, because for him it's more of a relativized a priori, meaning here kind of a Kuhnian approach where we're in the paradigms. It has some kind of strong presupposition that you would not revise unless you have really, really, really good reasons to do it, and therefore it becomes some kind of an a priori there. Kuhn himself, actually, in his later work, which Pihlström and Friedman are really emphasizing it, is saying, yeah, I've kind of, Kuhn himself says that he has some kind of a priori Kantianism there, like a tame one, but that's what they're grappling on. So it's not about physiology there.
Okay, thank you.
You're welcome.
Questions?
I may have a quick question.
You're all scared.
I did not understand something is also a good question. Totally legitimate.
Universality.
Yeah.
It's a naive question, but why keep this word, except I guess that it's because it's from Kant and Neo-Kantism, but why keep this word if relying on Pihlström approach of Helmholtz, you want to build some sort of situated knowledge epistemology?
Mm-hmm.
And if it's situated, it's not universal, so it's relative to contextual, social, cultural context and so on. So why keep this word precisely?
Because they are keeping it. that would be my no. But I think that there are two elements there. What I would use is intersubjectivity. I think that's the right word. If you want to go, I was searching for that yesterday. Kant uses a word in Latin to separate the notion of like rationality that God has from the rationality that humans have. So it can still be interesting to talk about universality in those ways. But no, I would say intersubjectivity there, but it's a strong one. So it's not simply like I'm giving you my values, your values, and we're just seeing like if you like ad hoc hypothesis, if you acknowledge them as being really important or not. Those are Feyerabend ideas or stuff like that. But people like Friedman are still using those. Because, and I think that's the second part of my answer, I think there is a way when people are building a canon, when they're going back to Kant, that how they're going to, the type of concept they're going to use are, like, you cannot talk of Kant without talking about necessity and universality being the two properties of a priori. It's really hard. Though I would say, I think there is also in Kant this kind of intersubjective interpretation. I think it's there in the Prolegomena, among others. But to me, go and use what Helmholtz is actually using as a framework to be able to interpret what we're doing today. Not go back to Kant and then you're stuck with this. I will have to relativize that. So yeah, for me it's more of an intersubjective. You can have a cycle of like first person or third person one.
Alexandre?
Yeah, I had a question about his question, but now I have a question about your question. You say intersubjective, but there's many ways to understand intersubjectivity.
Yes.
It could be, okay, we are all the same because we are the same species and we have similar blah, blah, blah. Or it is intersubjective because we agree about judgment.
Yes.
So for you, what kind of intersubjectivity should we, I'm sure you will say both because that's German philosophy, but what kind of intersubjectivity is aiming at Helmholtz?
And it's even worse. I'm not only doing German philosophy, I'm also doing naturalized epistemology, which tend to also bring those together. So I think I would say both of them are there. Yeah. But not exactly on the same, like there's a differentiation we have to do there. You have the psychophysiological universality, the fact that it's not about how my categories are shared not only by humans, but also any kind of rational being people that I don't understand. So it's psychologically driven, it's basically humans. One could maybe extend that to some animals if you're really looking at some elements. Most likely they know causality or being able to track objects. What's important though is when we come to what you say, intersubjectivity and judgment, and there to me there's a whole range of what does it mean to agree there. Then that's where basically you have a lot of stuff that are done today about whether it's good reasons. And for Helmholtz, I think if people acknowledge, aside from the psychophysiological one, this kind of intersubjective epistemic values, the only one that they would put forward is causality. Like law-likeness is a condition of possibility for doing science. But what I tried to show, I did not have enough time, but is that you have many layers there. You have many discussions where to be able to agree on how we do science, it does not only need causality, but you would need to talk about what type of explanation do you want to have? Do you want them to be perfectly coherent? If they're not coherent, if they're not explaining a lot, by, for instance, assuming that you are, that your innate hardware physiology is explaining how you have vision, that's a possibility we can have. Maybe it does a good, like it's kind of circular, but it does, you can use it as a regulative hypothesis to do science and try really to examine how your eyes are working. Maybe you would like to have more than just a circular explanation and really have something that can explain by going into how your brain is actually processing that kind of information. So that's one thing. Ad hoc hypothesis, do you use them, do you not use them? There's huge debate that are coming from either a Newtonian perspective, when you say you cut them as much as possible, you introduce them only if when needed, or you have the Feyerabend approach where you're like, that's how you do discoveries. Everybody is doing ad hoc hypothesis. That's not like, yes, in the ideal you would avoid them, but that's how science evolved. And there you still have some kind of intersubjective reasons, but those are more rooted into how groups of scientists, programs of science, how did they work. But my goal here is to say, stop putting Helmholtz strictly on a physiological approach. There are much more in what he's doing that is to be exploited. And that basically leads to a lot of debate we're seeing today. So I'd say there are more or less, let's say, restricted notion here of intersubjectivity that can be used. Yes.
Yeah, I have more of a sort of curiosity question about Müller. Who was this guy?
Müller, Johannes Peter Müller. Johannes Peter Müller is, good question, I can, Johannes Peter Müller is part of, let's say, the last vague of Romanticism, and also the beginning of the movement in which Helmholtz is the institutionalization of psychology. So what I did not tell you is that having labs in which you're doing psychology does not exist before the end of the 19th century, with the first people being Helmholtz, being Wundt, among others, that would really gather scientists in the same place, and they're going to do with objects, do really experiment, try to measure, put a metric on color. Before 19th century, really putting a metric, being able with vectors to predict what kind of color should arise, does not exist. It's Helmholtz that is actually doing that. Müller has this theory that Helmholtz really likes, which is basically what he calls the specific nerve energy. So the idea there is that you have different senses, smell, touch, and everything. For Müller, you have one type of nerve for each and every type of sense you have. You have basically, I think, five nerves. And the second thing is that he has this explanation where you have some kind of metaphysical fluid, this energy that flows, that allows you to explain how through your nerves they're circulating. What's novative is actually that he is emphasizing the notion of nerves there. And what Helmholtz is going to say basically is to do two things. The first one being, we want to avoid any kind of metaphysical approach there. So Friedman, good point, it works. And incentivize measuring device. So Helmholtz is actually the first one who will measure the speed at which the nerve inferences are running. So there's a speed when I'm touching something before my brain sees it. So most likely you all know that you're a little bit lagging compared to reality. So Helmholtz was the first to measure that. So that's the first thing. He has a more quantitative instead of qualitative approach. And the sense perception, or his sign theory, is actually coming from just revisiting this notion of nerve energy that is in the Müller, to have something that is actually defining what you see. How do you relate to reality? So those are the two elements where, and it allows me to tell you that Helmholtz is now the people that discovered how quick your nerve impulse are getting through your body. So yeah, that's Müller. He's part of like a whole bunch of people at the end of the 19th century that are all trying to have really this materialist, physicalist explanations.
Please, Alexander, please.
Oh, well, I'm sorry, it's just that there's a lot of stuff that I do not understand. So, it's related to the question, your question is, what is the status for most of the dimensionality, rigidity of bodies? You said it's factual observation, free mobility, because free mobility, I understand, okay, it really differentiates Euclidean and non-Euclidean, but rigidity of body, it's exactly the kind of thing that Poincaré would say, this is a pure convention, it comes from nowhere.
Sure.
So for Helmholtz, what is the status of these? He wants to replace the Riemannian axiom because he believes it's not well-founded. So what are they?
Yeah. What Helmholtz wants to do, he receives Riemann's thesis, the Habilitation von Riemann. And Riemann basically has this really mathematical approach to space dimensions. and then to geometry. So what he wants to do is just to operationalize that, to be able to use it in physics. So it's a translation into what he called facts. Those are super Kantian move. What Kantian are normally saying is like, I have those given facts, I'm giving the precondition of possibility for that to exist. So those are facts, really, of objective measurement. So give you that. Rigidity of body, it's a convention. Sure, that's Poincaré's point. Perfectly, that's Poincaré and Schlick's point, actually. Schlick did also the same thing. The idea there is that to be able to say that you have something that does not change, you're assuming basically that you have Euclidean geometry that is already there. So there's something...
You want to use that to differentiate between the two, so it's why I don't understand.
It doesn't work. I totally agree. That's normally when we read Helmholtz, for people who read Helmholtz, it's either for this psychophysiological approach or through that kind of criticism. It's for Poincaré and Schlick to say like those are conventional, just a conventional dimension.
Yeah, but on the other
not
hand, when you say operationalize, that's interesting because if you're a pragmatist, you would say, okay, for us, we live in an Euclidean space, whatever that means. But we want to do science with more than that.
And therefore,
okay, we can assume that there's some fishy part of our...
Yeah, sure, that you can expand on. And so, yeah, sure, that's exactly what Helmholtz is going to do. The only...
He's really a Neo-Kantian. Because at the end you were arguing he was almost a William James.
No, we're not go. I will not go that far. But the reason why I put that, and I think thank you for that, because that's eventually a link that hasn't been done that I'm working on. And you have also the we with functionalism and stuff like that are not really far, that have been noticed by a lot of people, but not really fully explained. Why I was presenting him as this is that normally what you have is Cohen, what you have is Natop, what you know is let's put Cassirer aside. I like it. Or bad school, Rickert, Windelband. So what you have are really, let's say, more idealistically driven philosophers there that kind of create this, like we like in history, we're building differences. So you have the Marburg school, and then you have the American pragmatism. You have Heidegger that goes after the Marburg school. So we have some kind of really putting that into constraints, but Helmholtz doesn't fit into this Marburg school. Like that's not at all. We're not talking about like infinitesimal principles are kind of used, but they're not like that's not Cohen's work that we're doing here. My point there would be that just before those people, there would be a lot of people that are there. Among others, there was part of my thesis, Friedrich Albert Lange, which is basically somebody that was read by those pragmatists, among other peers. Who has basically retaken Helmholtz's work. There's a lot like the same arguments about the kind of naturalized approach, the same thing about functionalism, the same thing about the empiricist approach. Those are all in Lange also. So there are a bunch of people that thinks the same, that wants to not have anything that is really metaphysical, but have a kind of pragmatic naturalized approach there. And I think those people are not... They're known-ish by a community of people that have interest into Neo-Kantianism, by people who are reading often Vienna Circle as being like this pinnacle of beginning of the 20th century. But that sheds light, a weird light, on those people as like, those are the weird people. That Helmholtz is the person who did some mistakes. Sure, there are mistakes. Mistakes they help us learn, and there are reasons also, and those are the things that are of interest to me. But I totally agree with you. Those are Neo-Kantian people. Those try to bridge some, to have a physiological approach. They're not doing just psychophysiology. That's normally how we know through Husserl, Frege, those people. So that's what I'm trying to give them a voice.
Okay. No, mine is just comment on the fact that the pragmatists would say that we actually live in a Euclidean world. There is this book by Patrick Heelan, which is space perception and the philosophy of science, where he notices that actually in our everyday experience we sometimes live in hyperbolic geometry. For example, when we look at the sky, or when we look at distant objects, and that the Euclidean reality is basically limited to what he calls the Newtonian oasis in the center of our field of view. And I was thinking whether this could be interesting to compare with these considerations we were carrying on about Helmholtz's observations on this. And I also have another question on the fact that you mentioned that you explicitly talked about the external constructed world. So I was curious to know how much constructivism is indeed there, and how could we, and if you could say a bit more about the recovery of the objectivity in science, given the amount of constructivism involved in this, your perspective on Helmholtz.
Yeah, it was Patrick Helon?
Patrick Helon.
Helon.
H-E-E-L-A-N. He's basically a Husserlian.
Yeah.
Okay.
Yeah.
Okay, so the first one on your comment, I totally agree. I think Helmholtz doesn't play a big role in what he's saying. It's not game changing, but he talks among others in mirror inference that you have when you're seeing like those mirrors that are deforming yourself and you look bigger or smaller. For him, that's one of the example we can have of living in a non-Euclidean world. Another possibility, he's not talking about it, but people know that for ages, which is basically how do you project, how do you map the Earth on a 2D plane. That's also a way where you have all of those problems or representation that are arising there. So I think it's not foreign to what Helmholtz is actually thinking there. As for constructivist, I will ask you to be more precise, like what do you mean by how much constructivist? Because I can go and I think there will be a lot to be said on how do we search structure, for instance, invariant structure into reality. Either here it was really through measuring, for instance, objects. I think it is the same when we're talking about measuring color. So there is some kind of a structure, it's an empirical one. Helmholtz tried at first to have really this a priori structure put on colors. It doesn't work because then you would be predicting colors that you're not experiencing, for instance. There's a good book if you're interested by David Hyder, who's describing how we go from this. But I think the point there is some kind of structure that should be there in reality. It's not sure that they are really there, but when we are applying mathematics to it, you're kind of assuming that they're there. So that's how I think, let's say the constructivist elements that I could put there, but it depends on your question.
Yeah, no, my idea of constructionist was that scientists are not really discovering something that is already out there, but constructing it actively.
Yeah.
So I was curious to understand how, in the specific perspective you attribute to Helmholtz, from this point of view, we can recover objectivity in science.
Okay. I will rephrase what I said in I hope, more clear way to understand this structuralist approach. The idea there is that as long as you can have mathematical equation that can allow you to describe the behavior of something, you have something. You don't really know, like, is it existing aside of me? Is it simply me that is projecting that? There's mathematical equation. It allows me to grasp some kind of structure. Then you have auxiliary term you can add to it if you want to talk about light being a wave or light being a particle, for instance. For Helmholtz, that's okay. That's contextually dependent. At Helmholtz times, you don't have those two theories. Let's say the field or wave theory is appearing during 19th century. It has not been unified. So what he has is, we don't know exactly what light, for instance, is. It has weirdly two properties, and those are kind of two, it's not exactly the same kind of mathematics that applies, but as long as you can do math and fixed equation that allow you to predict how the behavior of a field of vector is going to act, for instance, call it a wave, it doesn't give more reality to it. But there is some kind, those equations are grasping on something that is there. I don't know what it is exactly. I don't have access. I have my nerves. I have a whole filter that is behind me. So I don't have access directly to it as a transparent approach, but there is something there. So that's how I would say, like, it's fairly constructive because the concepts are not so much important. Those are part of a theory. They make sense together, but waves do not particularly exist outside of, like, the equation tells me that there is something that behaves like a wave. But to know that it is exactly that structure in reality, there's some kind of underdeterminacy there. But it makes sense. You can predict how it works.
Yeah.
So
we have equipossible ontologies on which we can choose, but the objectivity is ultimately given by the fact that we have equations that can be useful in our interaction with.
Yeah. To put it into the talk's terms, what you have is you can define what a meter stick is in really weird and problematic ways, but you can define what a meter stick is, you can measure the space, and therefore if you want to do it through an object or in a real physical approach, or if you want to do it through this phenomenalistic approach, using simply the concordance of Hülle or sensitive signs, that's up to you. You can choose them. Most likely you won't choose this one because it's a really tricky one and complicated, really more easy to talk about objects that are outside. But what's important there is that you have a choice. You can do both of them. You can think of yourself, the term that Helmholtz is putting is either you think there's a world or you think that you're in a dream. That's not really important.
But isn't there the idea that, to me, it seems to emerge from the semantic of science Helmholtz uses, that there is actually a real reality behind the possibility to characterize the world from the point of view of science. So it seems that there is something that gets quite close to a Kantian phenomenon in this specific choice of using the semantic of science.
Yes.
How much is this true?
That's at play. You're totally right that this thing in itself, noumenon, is at play in those distinctions. How much does my representation showcase something outside of it? But Helmholtz, if you're looking into how his thoughts evolve, there is really an evolution from a really causal, realist approach where you have something, I don't have access to it because my nerves, what I understand is my nerves and not what's behind, into something that I would say looks a little bit more like a Quinian approach, some kind of underdeterminacy of what's there.
Okay.
I cannot know it. That's what I have as a stimulus, and the only thing I can say is those signs that are showcase me an X, like it's a limit concept, one could say in the...
But still it resists.
It's still there. It's still there, for sure.
If he has Fichte.
But it's from within, so it's like there is this X that is there, that is behind. Either you're having a big picture, like a God-eye view, a view from nowhere, and then you say you have the subjects and you have this X that does not exist, or you're from within this perspective, and then you have this differentiation.
Yeah, but the difference with Kant is Kant is passive.
Yeah.
So you have some kind of causal relation, and you can doubt of it when you think about it. And
Yeah.
why would I have a causal relation to something that cannot? But with the Fichte
It switches.
addition, is like it's a relation.
Yes.
It's not object, subject, trying to know the thing. It's I will hit the damn thing and see what happens. Of course, I cannot differentiate necessarily my will completely from the outside, but it's a relational approach.
Yeah. So the idea, and that's always the first move that every naturalized approach has, is to remove from this God eye views. They call it always like that, this view from nowhere. And it's really seeing like, there will be a frame. Like, call it as you want. It could be physiological, like Pihlström has a whole list where he lists like everybody who suggested those frame dependence and dependence. Like, there's a whole possibility. The thing is that when you sit between them, what you have is a split. From within that relationship, you have two poles that are pulled apart. That was hard. And what you have is this scheme dependence, independence. Something seems to be independent of your scheme, seems to resist your scheme, but there are stuff that you can really see, like that's me that is just constructing it. So that's from within this that you have. And I think that's what we see as this kind of transition in Helmholtz, from this really realist approach, subject objects, into this folding, unfolding approach, which explains why there's a lot of what do you mean here moments. Welcome.
Thank you.
Welcome. Thanks.
Julien, finally.
I don't know, it's ringing. Maybe I don't have the time.
Go ahead.
Okay,
We start
just a very quick question. Why, in the three axioms that you showed earlier,
Yes.
why is there n dimensions? Why is the manifold n-fold and not like threefold? Because if it's a factual axiom,
N-fold instead of?
three. If it's space, I mean, why n? Why that level of generality? If
It's the level of generality that you have. That's a good question. That's the level of generality that you have in.
Riemann?
Yeah, that's how Riemann defines it. The thing. Yeah, that's actually a good question. I guess he wants to try to avoid actually what he is doing. That is presupposing that it is Euclidean geometry that actually works there. In Euclidean geometry, I don't know, like I've never tried to understand if it works in fourth dimension or even how you could represent it. I would guess so. Yeah, I think there it's really coming from Riemann. That's a good thing. And I think he's just trying to avoid presupposing that it is really rooted into the world we have.
But it's a long, long time ago, so you have to check. But if I remember correctly, Riemann, is it first they start to discover this new geometry in 2D. So sphere, hyperbolic stuff.
Yeah.
So after that, they ask themselves, could it be in 3D? And Riemann, in his habilitation, is saying, okay, let's forget about that. Now we're always discussing about example, and he's beginning to develop the Mannigkeit. So the idea of manifolds as a set of stuff without structure.
Yeah.
So I think it's where it's pretty natural when you say, okay, I will get rid of structure, what do I have finally? It's a dimensional set.
Yeah, I understand that, but from Helmholtz's perspective, it sounds a bit strange.
But if he wants to operationalize Riemann, he has to start from Riemann.
Yeah, but you cannot operationalize n-fold. You cannot even.
You have time and you have 4 dimensions.
Space here is not space-time.
You can do equations. You said if there's an equation, there's some kind of potential object. So
Yeah.
you can do equations in many dimensions.
Yeah. But I'd still say I think it's like I would agree with it coming from Riemann. That's to me the obvious way to go. The thing that is interesting there is not only do you have time and you have that, but if you think that space is not uniformly curved, then basically you have Einstein. That's where it is coming from. Where you think that, let's say, the fabric of space and time is not simply like uniformly curved, but that it changes regarding the quantity of matter you have, so that you end up with this like field that is influenced with
But
matter.
then you don't have free mobility of bodies.
Then you don't have free mobility of bodies. So that's just like starting to remove Euclidean geometry from the fabric of space and time. And then that's why it is super interesting to see like what is motivating those change. And that goes super quickly. We're talking like 78, then you have Einstein, which is basically turn of the century, and you already, like, that doesn't work anymore. It's interesting to see those, how do you construct or operationalize Riemann's ideas there. And those were really important elements. But yeah, it's like...
Next questions with a beer. Thank you.